Hello Internet, welcome back to our Voxel terrain video series. It's been a while. I completely destroyed my computer last week, and that was a mistake. So I completely blew up the first BIOS on my motherboard and the hard drive that my operating system was on. But we're back now. Things seem to be working, so hopefully this is the first video I'm doing on my newly installed version. So one of the cool things that came out of that is I actually put together a script that can actually reinstall most of what I need for this. So most of what is actually on this computer right now was all installed via script, and it's all in actually two scripts. That if you run those, it pretty much installs everything, including Visual Studio, Unity, Steam, and a few other things. So if you don't know, I have a blog where I post a few other text-based things. And so how to actually run that and the code for that is going to be described there, because that work is already done. I'm not going to walk through that here because I don't want to break my computer again. But anyway, if you need that, I'll put a link in the description so you can check it out. I think it's pretty cool. It looks at PowerShell, so if you've never used that before, you can check it out. But we're here, and what we're going to be doing is right now, we have this fancy mesh. This is actually what I used to generate the title for the last video, but it's just a ton of quads. I don't know if there's a way to count these, but it's a lot. Like a lot. So what we want to do is we want to take this and generate a single mesh from this, and then use that in place of all of these individual quads. So for this video, we're not going to be doing anything special. We're literally going to be duplicating this logic. We're going to be generating quads, but they're all going to be in the same mesh. And then the idea is, hopefully we can go back and actually run that through some algorithms and condense the vertices down. And then the idea is to actually run this through probably marching squares and get that smooth. Because you can see we've got some pretty significant edges here. There's a zoom feature built into the editor now, so you can actually just zoom without having to move your camera. But you can see all of these sharp edges. Those are there because we're using quads. We can get rid of those with marching squares, and so that's going to be something that we're going to be working on. But for now, let's get into actual mesh generation. We've already done this, so it shouldn't be too hard. But I'm doing it, so it will probably go horribly wrong. So we have a quad mesh creator, and this is just generating currently a bunch of quads using the primitives that we had. I don't think we need to keep this because I think this is a terrible idea. So I'm just gonna modify this, and I think we can go from there. Ah. All right, so what we can do is we are currently just creating a bunch of primitives and then sticking those in. And we had to stick all of these references in here that we're not using just so that they don't get cleared up by our mesh creator. The thing is we're still going to need these actually. So I'm going to delete them for now, and we'll come back to those. They'll be making a comeback. Right now we generate a mesh and then set generate to false. What we're going to do is when we generate that mesh, we're going to create a new game object, which is going to be our mesh. And this is actually going to contain our mesh render. And so we want to do a game object dot instantiate. And actually, we don't need to do that. You can actually just do a game object and create a new game object like this, and it will do the same thing. So just to demonstrate that, if I give it a name, and I think all of my IntelliSense is broken. Did I not? I may not have installed the Unity plugin for Visual Studio. Oops. Anyway, we're going to give it a name, and we're going to call it test object. What we should see is when we click generate, instead of all of this stuff, we should just see a test object get created, and it should be created right at 0, 0, which should be fine. Oops. Yeah. So we can just keep creating these test objects over and over. So what we want to do is actually attach that. And so this is going to be our voxel chunk is what we're going to call it. So that a chunk is just going to represent the voxel data for that specific octree. And so a stretch goal of this project is to actually be able to stitch multiple octrees together. So if you move multiple right next to one another, the voxels will actually align going across. And so theoretically with that, you can make infinite terrain, or you can make it bigger than a square. So that's part of that, and so that's just part of the chunks. So you could have multiple chunks in the long term. So what we want to do is set the transform dot parent equal to the current object we're attached to, and we're going to set that equal to the transform. So this just parents it. It's the same logic we had. We're just doing it this way. And then the only other thing I'm going to do is set the local position equal to the vector 3.0, which is just going to center it inside of whatever object we're attaching to. And so none of that is super important, but all that's going to do, instead of putting our object just inside of our scene, it's actually going to attach it to our quad tree, because that's where our generate is attached. And you can see it pops up there. And so what we need in order to render something, so if I put a cube in just for example, you need a mesh filter, which is going to describe the mesh, and then you need a mesh renderer, which is going to render your mesh filter. So we need to attach both of those components onto our new game object, which we can do fairly easily. We can just do add component, and we're going to add a new, I think it's just mesh filter. I'm going to have to slightly guess in the dark because I don't have the component installed that gets me IntelliSense. It was supposed to come with it. It was checked when I installed. I don't know where it ended up. I'll fix that after this video, hopefully, and we'll get it back. This is the first time I've spun up Unity or Visual Studio since reinstalling everything on my computer, so kind of experimenting here. We'll see how this goes. And then we just need a mesh render. And so we get both of those, and these should, if I'm correct, it does not appear that I am. No, it should be returning it, yeah. So I just need to do var our mesh filter, and this gets us access to both of these. And so I should be able to do a mesh render and set the filter to the mesh filter. And this just needs to connect the two components. I don't know what I'm missing, so I'm gonna go on a search. Well, that's kind of disappointing. Doesn't tell me what I need. Render. Going on a search. One sec. Let's see. We've got the materials. We don't care about those yet. We're looking for where our mesh is actually coming from. Actually, we can just ignore all of that and just pretend like it works. Because we will be getting to that point shortly. So this is going to get harder and harder without IntelliSense. So one sec, I'm going to actually kill Visual Studio and hope it comes back. We'll see if that worked. But anyway, we can test this, and we should now have a voxel chunk with a mesh filter and a mesh renderer attached. And actually, now that I'm kind of remembering things, our mesh renderer should automatically render our mesh filter. We shouldn't need to connect the two. So with both of those there, the next thing is to actually change this empty mesh into something cooler, which ideally is going to be all of our voxel chunks. So, oops, that's not what I wanted. Starts way faster now. So let's get our mesh creator back. And hopefully what we can do with this is actually more or less copy what we had. So we're going to have a copy of our quad tree. So for each leaf in our quad tree, doesn't appear to have helped any. That's too bad. I believe we have a way to list, yeah, the quad trees. We need to work on naming. Naming is getting out of hand. But we need to do our get leaf nodes. Quad tree, get leaf nodes. Sure. Inaccessible due to its protection level? Oh no, how are we doing? Oh, I see. We had a getter like that, just to prevent setting it automatically. It's been a while, okay? Right. So, with this, what we can do is actually super simple. All we need to do is set up our mesh filter. So this is actually really easy because we don't have to do all that much. We just need to create a new mesh, which we're going to be doing here. So I'm actually gonna take that. Actually, I can take all of this and move it down here. And then we want a new mesh equal to a new mesh. Sure. This can no longer be called that because that's not how that works. Chunk. There we go. We're actually getting decent names. Well, I say decent, I mean better than awful. So now what we can do is we can actually take this leaf nodes and generate our mesh. We're building the mesh here, and to do that, we need to fill out a few things. The first thing we're going to fill is going to be our triangles. So there's a bunch of things we need to actually set here, and that's going to be our triangles, our UVs, our normals, our indices, and where are they? Our vertices. And so each of those has to be created, and just for the sake of this, we're going to start out and we're going to say it's okay for certain quads to share their vertices, which means that two vertices may overlap and they'll still be two individual unique vertices. And the reason we're going to do that is because it's easier, and because then we can actually focus on mesh joining algorithms after this, instead of trying to optimize it as we're building it. I think this is the right direction. I don't honestly have any idea. So we're going to start here because in our previous video, we actually shared vertices. And so we're going to try something different and see if it works any better. So I'm going to make a new vertices list, and this is we're just going to spin up a bunch of these. So how does this work? I should have paid more attention. They need lists, so they're using array lists, it looks like. So that's what we're going to do. I was going to use a linked list because we're just inserting, and inserts are constant time with the linked list. But we're going to stick with the same data type they need so we don't have any conversions. So we need vertices and triangles, and what else? UVs and normals, I believe. Cool. So the triangles is going to be an int because it's going to be taking the index. Yeah, there we go. And then our triangles is that, which is another. Oh, wait. Sorry, I'm getting confused. Our normals and our UVs are going to be lists of vector 2s for the UVs, and our triangles are ints. So UVs there, and I meant to say normals because that's what we actually care about. So the UVs will be vector 2s for U and V. Normals are going to be a vector 3 because they're going to be three-dimensional. These normals are all going to be identical. Every single vertex is going to have a single single normal, and they're all going to be pointing the same way. That's just the nature of 2D. But for now, we have those lists, and so for every leaf node, we can actually generate. We can actually add things into our mesh. So before we do that, let's actually add them to the mesh. Set vertices. Ooh. And we'll set it to the vertices, like so. I think I spelled that wrong. There we yes? Yeah, there we go. Okay, we're gonna set the triangles, like so. Set the UVs. And we're going to set the normals, like so. And it doesn't appear to have liked any of that, so ooh, I don't want to get. We definitely want this to be a set. It's expecting a channel. So I believe 0 is the correct option there. Internal temp. All right, we're back. I overheated my camera. This is going really poorly. I apologize. So picking back up, we have our set triangles, which is going to take looks like a triangle and then the submesh. So we're all going to pretend like they're all in the same mesh. Pretty sure that's not the right way to do that, but we're going to be changing this anyway. So for now, all we're trying to do is just generate the mesh, replace all of those instances with a single one. So this should work. And now that we have all the sets configured, theoretically all we need to do is actually build the thing. And so for the leaf, we already have ideally everything we need. So let's build our vertices, our triangles, our UVs, and our normals. So we can add on to that using our vertices. We're going to add a leaf, and I believe if I can track this down, we're going to have a position and a size, and both of those are exposed publicly, so we should be able to tinker with them a bit. So we've got the leaf dot position. So that's going to be the 2D origin of our node, which is not necessarily what we want. So let's actually vector 3. We'll do the upper left. So that'll be up this way. My camera may be flipped, so it may look a little bit weird for you, but that's my left. Anyway, we're going to do the vector 3 of the leaf position dot x minus the leaf size times 0.5. Because the size covers the entire size, we're already at the center. We want to move to the outside, which is going to be half of the distance. And then we just need to capitalize the position like that. And then let's do that again for the y. And so times 0.5f. The only difference here is to get the top. Unity's coordinate system goes from negative up. So we need to actually add here to get the top left. And then we're going to have no depth, so it's just going to be 0. And so, ideally, assuming I did all of this right, we should be able to do the insertion of the upper left, the vertices dot add of the upper left plus a vector3 dot right times the leaf size, and that's going to move it to the right by the leaf size, so it should be the upper right, and then vertices. I have spelled it 3 different ways, and 2 of them are very wrong. We're going to do upper left, and we're going to do plus vector3 dot down times the leaf size. So this will get us the bottom left. And then we just need to duplicate that same logic for our other one. So the same thing we did here, both of those need to be used for the other one. So we're going to go down and we're going to go to the left. Vector3 dot left, or sorry, dot right times the leaf size. And that's going to get us our quad points. And so that should handle inserting our vertices. The next thing is going to be our triangles. And so for that, we're actually going to want to grab, what do we want to do? Let's actually grab the initial index. Initial index is going to be equal to the vertices dot length. So length, or count actually is what it is going to be the number of elements in an array, which in this case is going to be 1 greater than the maximum index because it's 0 indexed, but the count starts at 1, which means the count, if we insert something, that count is equal to what we just inserted, which means this value is now equal to this index. And so since all of those are added afterwards, we now know where it started and we know there are 4 of them. So we should be able to add some more triangles. And this is done by adding a set of integers, which is going to be the indices of your triangles. So let's do, excuse me. Yeah, so let's do top left, top right, bottom left, and then top right, bottom left, bottom right, which is going to be the initial index, and then the initial index plus 1, and then the initial index plus 2, and that's going to be our first triangle. And so there's going to be more of these. I should just copy and paste. There we go. And then we can copy the second one, which we said was going to be top right, bottom left, and then bottom right. And I think we have the rotation of those flipped, which means we'll only see one of the triangles, and that's just a culling mechanic. We'll talk about that more when we get to it because we've already covered it in a previous video. So a lot of what we've done in this video is covered in our mesh generation tutorial. So is it a tutorial? I don't really like calling them tutorials. It was covered in our mesh generation video. So if you want to see that, head over to that video. We do deforming terrain in that video as well. So anyway, we've got triangles. And now let's just insert, actually, it's probably good enough now that we might be able to see something happen. One way to find out. So let's see. One thing I have also changed is I made my entire Unity tint red a little bit when I'm in play mode, which is why it looks a little bit funky. That's just so I stop modifying things when I'm in play mode, because I was doing that a lot and it was kind of annoying. There's 0 vertices and 0 triangles. Something's not quite right. Why would that be? Vertices, triangles, magic. Why is there no magic? That's disappointing. Oh. That's why. Right there. There. Fixed it. Assign the mesh. That ought to fix everything. It's amazing what a logic error can do. It can make things not work. Okay. Let's run that. Ooh, that is either pretty or awful. I can't tell which. Okay, so we are getting the triangles. It looks like our first triangle is correct. Our top left, right, and then bottom left is correct, but the other one is flipped, so we'll get it on the other side. And there's no materials, that's why they're pink. That's fine, we can fix that later. But, actually, we should be good. The only thing we do want to fix is I want the UVs to be based off of position, which is going to be super simple. We just have to actually do it. And so, unless I'm very much mistaken, the UVs should match up exactly with the vertices. So we should be able to do that. And then we can just add in, actually, those values. And that should work. So the reason I'm doing this is I want the UV values to match up to the positions. And the reason for that is so that it tiles and you actually have a unit of distance that you can use in your tiling. So if I actually apply a material to this, which we'll do at the end, I'll actually throw a material on here and show you what it looks like. But when we do that, this is 8 units long, which means we can tile our texture 8 times, or we can change the texture scaling to actually texture differently. Whereas if we just stretched it across this, it wouldn't scale well, because it would actually stretch everything, and that's not great. So if we actually increase the size of our octree, everything would just stretch out if we did like 1 to or 0 to 1. So this should fix that problem. Then the other thing is actually going to be another copy and oops, going to be another copy and paste. And that should just be our normals, which we can just plug in as a constant. Don't know if it's forward or backward. I think it might be backward. Back. There we go. Got it. It's all right. It's all right, everybody. I got it. All right. So that's going to set the normal value, which is the direction that the material is actually facing. So like my desk is facing up, for example. I already used that example. But the camera is facing, that's normal is that way, and so forth. So you need the normal to be in the opposite direction of the light, otherwise it will look funny. But I think we've got everything. We've got our vertices, our triangles, our UVs, and our normals, which means everything should be generated. The only thing we need to do is actually flip this second triangle. And so the easy way to do that is just flip the third and the first vertice so that the rotation is the opposite direction. If you don't understand rotation, see the other video. It just has to do with how culling works in 3D renders. So we have that. I'm going to add one final thing, which is going to be the mesh render dot material. And we're going to set that to the default or the voxel material. I guess we can call it the voxel material, sure. And so that's just going to be passed in like so. And that should automatically texture our voxels. And so the advantage of this is, one, it should be much faster. And it is. And two, it should be a lot better. One sec. We're going to pick, what even is this? Spatial mapping wireframe material. I don't know what this is. I have no idea what this is, actually. Legitimately, zero clue. But we're going to stick it in there, and... Whoa, what is going on? What have I there's some weird thing going on with this material. I like it, but I think it's using screen space, which is not what I wanted. So there's some special shader going on with this thing. I just wanted to see what it was. Anyway, that's irrelevant. What we have is we have a fully generated mesh. I'm going to switch this to something less insane. I will do just the default material just so you can kind of see it happen or it work. And that should be enough. We'll generate it. There we go. It's lit. Everything looks good. It looks the exact same. The only difference is we have a single mesh doing all of this. And so theoretically, I don't know how long it is actually taking to generate that. So quickly, let's just figure out how long it takes. So there's a system. I'm going to have to figure out where this is. I think it's under date time. Okay, I pressed all the wrong buttons there, but I think it's here. There is a way. No, this is the wrong spot. It's called a stopwatch. And so a stopwatch is going to be a high precision debugging tool. You shouldn't actually use it in many places, but it's pretty nice because it gets you, I believe, it depends on the CPU, but it can get you down to like nanosecond precision, which is really nice for profiling because some things happen really quickly. If you're comparing like datetime.nows, that's not going to be anywhere close because I believe that uses your system clock, which is not even close to that precise. So if you need really fast profiling, use this. Unity also has a profiler, but that might be a little bit hard for what we're trying to do. So all we have to do is start it and stop it, and then debug.log stopwatch.time. I don't actually know what's on here. I know there's a start and a stop. Let's grab our elapsed milliseconds. And now it's yelling because there's a confusion because I included a system library that also has a debug class. We should fix that. And so what we should be able to do is actually generate this a bunch of times. And that took 43 milliseconds. So that is going to be pretty dang quick, actually. Like, if you're running at 30 frames a second, that's less than a frame. That's significantly less than a frame, actually. One sec, let me do the calculation. So, if you take 43, and that's not how you do that, take 1,000 and divide it by 43, 23 frames a second. So, we drop down to 23 frames a second, and that's if we do this all on the main thread of our application. I think we can get this running pretty dang quick with what we have right now. And that's if we regenerate the entire mesh, not even caring about only the parts that were changed, which are quadtree, or our quadtree is going to give us a lot of advantages there, because we can only update the mesh in spots that were updated. So in cells that were updated, we can update those. So I think we're pretty close to where we want to be. They're squares, which isn't great, but it's pretty quick, and I like quick. So that I'm going to leave that here because I'm not entirely certain that this even worked. So hopefully you'll see this later tonight, and if not, then my computer is still broken. Oops. Not much to say there. But anyway, if there's anything you guys want to see, anything you guys, any feedback or suggestions you have, let me know in the comments. I read everything you guys say. So if there's something you want me to change or something you think is interesting that you think we should try out, let me know and we can look into that. If there's something that you think is wrong or that doesn't really fit or you don't understand, let me know about that as well, and I'll do my best to walk through what we're doing. So I think that's it for now. So until next time, see you, Internet.